welcome back to my teaching channel. So this video, I will show you the last question in the calculus course online, unit 2, unit 1, about, actually unit 2, about the application of differential equation. So this question is in terms of finance and money. It sounds interesting, right? Everybody love money. Now the reason I love money, that's why I'm standing here and try to upload on the videos and hope that I have millions of viewers around the world to watch. So that I can earn the money in a meaningful way, which is I give out the free education. I don't know about you, but for me, I always remember and appreciate my professor in the university who has given me a great support in Louisville College, the college when I went through. And they give me support, strong support, and great compassionate support to help me to achieve something I love. I love teaching and I have a passion for it. So therefore, I really appreciate all my professor and my teacher in the past. Sometimes I understand that education is boring and like there's a proverb in the English, I remember. Those who cannot do anything are those who teach. That's our philosophy of North America, right? We don't look at that way in our Asian culture. We really appreciate the teaching and education. I speak for myself, maybe, I don't know, but I know I came across both value in the cultural crossing. So I grown up in the culture, like we very treasure the teachers' compassion, and they're educated our children, right? So I don't know myself. I love my teachers and I really appreciate them, to be honest. Anyway, let me get back to the question. So I have a financial question on the board. George has a saving account with a balance of $4,500. This account earns 6% interest per year, compounded daily. He plans to withdraw $30 each week. For 3 years, he attends college. What will be his bank account balance when he graduates? Okay, so it's an interesting question. So let's write out what is the summary. Given interest equals 6%, which is 0.06, his money draw, right? Money in will be 0.06 times with whatever balance in the bank. And the balance in the banks, we cannot be zero. At the beginning, equal 4,500. Then after a while, it draw and the money out withdrawn. He withdraw $30 per week. Okay, so if we summarize this question that are given, it seems to me that this question is complicated because the money draw is in daily and it's not even continuously drawing, like continuity. So it's not the law of natural growth. And the money withdraw, he withdraw in weekly. So it's kind of complicated. And if we use a financial formula, we have a present value equal something like the money withdraw each month or each year represented by R times with 1 minus something like, if I remember correctly, is something like over m, then m times with n here and minus, right? The reason we have a minus because we want to get back to present value, something like that. But anyway, thank God that we don't have to use this complicated equation in finance. We just try to, and it's hard to use that too because we have a compounded daily money row, but money withdraw is $30 each week. So if we use a formula in the bank, we have to do something I don't know. But anyway, thanks good that we use a calculus differential equation to solve this problem. So let's see how we're going to solve it, right? So we know that the money row is derivative of the bank balance, dB, let con dB is the bank balance, right? dB over dt, respect to time, will be equal to the rate of money in, subtract the rate of money out. So now dB over dt will be equal, rate of money in is 0.06 times with the balance in the bank, whatever the balance is, represented by B, right? Minus rate of money out is $30 time with, now let's calculate T in year, right? In 1 year. So T in 1 year is 52 weeks, right? $30 per week, we have 52 weeks. And of course, this will be time with delta T, subtract this time with delta T, right? So simplify this. So this is the first bracket, and this is second bracket. Simplify this, we have dB over dt equal 0.06b minus 1,560, right? All of this with time with delta t respect to time. So now to be able to lead this y function, so this is like y prime, we have to withdraw the k, like remember y prime equal ky. So we want to withdraw the k value. So I'm going to put ratio 0.06 as the k value outside the bracket, right? Inside I have b minus. Now this number, if I put out as a multiply as a factor, this have to divide back to compensate for it, right? So this turn out dB over dt, and I can write this as b minus. Now this number turned out to be what? If you divide this with that, you got 26,000. So this is minus 26,000 over dt equal b minus equal 0.06 times b minus 26,000. Okay. So basically, if we pull this out, we have b minus the balance minus 26,000 will be equal. Now I'm going to change this become c to the ekt, right? And now k is 0.06 times with t. Okay. So now how do we solve for the c? At the time t equals 0, the money in the bank is $4,500. Minus 26,000 will be equal to C, E. Now, if t equals 0, e to the power 0, right? The whole thing here will become 0. So because c is 0, so we can cancel it like equal 1, right? Now this number will give us minus 21,500 equals c. So now we know c. So plug back into the equation, we will have our original equation like b, t, right? Equal if I transfer this over, I will have 26,000 minus C to the EKT, and now C 21,500, E to 0.06 times with T. So that is our equation, okay? And this B stands for the Y function, right? YT, the original function, f of x, after we differentiate it, okay? So let's calculate this and find out how much money left in his balance account. So 26,000 minus 21,500 times with E to the power 0.06 times 3 years, because we substitute this by 3, right? So this B here we substitute by 3. So we have 26,000 minus 21,500 E to 0.06 times 3, because after 3 years, right? So enter. I did something wrong. Wait, so let's calculate 21,500 times with E to the power 0.06 times 3. Enter. I got this equal 26,000 minus 25,740, right? You see it from my calculator. 25,740.17. Okay, so let's subtract 26 equal minus 259, but actually we have to change the sign because I just enter for convenience. It's supposed to be positive, okay? 200. So this amount equal $259.83 if we calculate it round off. So that is how much left. So this is what? His money left. His money left after 3 years. Okay, so that sounds reasonable enough because he had to spend, he withdraw $30 each week. So that's the amount left. So if we assume this is a continuously growing and we apply the calculus differential equation, we get a very close answer, okay? Not quite accurate, but it's very close, approximation, and it's good enough, okay? So I introduced you a lot of word problem, right? I show you how to solve differential equation. I also show you how to apply to the law of natural growth, money, and then what else did we do? The solution mixture, right? So I hope that if you register to this course, you will have all of the material, the videos, rewind and watching, and you can have a practice exercise to solve and earn your own skill. So I hope that you will be interested in my online course. Anyway, thanks for watching for now, and see you. Stay tuned for the next lesson. Bye for now.